In this video, we're going to learn how to factor quadratic trinomials by grouping. Here we're going to do this algebraically with parentheses, but you can see how to do this with the visual aid of an area model in another video. Let's begin by reviewing factoring by grouping, which is a method we can use to factor expressions with 4 terms, and we have an example here. A good first step when we're factoring is to always look at all the terms in your polynomial to see if there's a greatest common factor. These 4 terms have nothing in common other than a factor of 1. So now we can look to grouping. It's important to remember that the grouping method doesn't always work. And the rule is this. Factoring by grouping only works if the product of the first and last terms is equal to the product of the middle 2 terms. So let's look at our polynomial. The first term is 8xy, and we'll look at the product of that and the last term, negative 15y, and we want to know if that's going to equal the product of multiplying the middle 2 terms, 20x and negative 6y squared. And sure enough, we see that on the left, we get negative 120xy squared, and on the right, we also get negative 120xy squared. So the fact that these are equal tells us that the grouping method will work and that it'll work with the terms arranged the way they are now. So now let's begin the grouping. Even though all 4 terms didn't have a greatest common factor, the idea is now we'll just group 2 at a time. So I'll group the first 2 terms together and the last 2 terms. But let's remember terms are separated by addition, so when I see subtraction, I really know that means I'm adding a negative term. So let's show that and keep the sign with its term. Now let's look at the first group. What do those 2 terms have in common? 8xy and 20x both have a factor of 4x, and when I factor that off or undistribute it, on the first term I have a 2y left, and on the second term I have 5. Now let's bring down the addition symbol and look at our second group. Those 2 terms have a negative 3y as a greatest common factor, so I pull that out. And what's left? On the first term, I have a positive 2y, and on the second term, I have positive 5. And we can check that by redistributing that negative 3y to see that we get my original 2 terms back. Now I want to point out what we have. We really have 2 big terms here, underlined in red, and notice they're separated by addition, as terms are. And that both of these terms have a binomial factor in common, 2y plus 5. And that's exactly what happens when we successfully factor by grouping. So now what I'm going to do is I'm going to pull that factor, 2y plus 5, off of each of my big red terms. And what do I have left? That's my other factor. On the first term, I have 4x, and on the second, I have negative 3y. And so now I'm done factoring, and those are my 2 binomial factors of my original polynomial. You can check that by multiplying back out. So now let's look at an example of a quadratic trinomial with 3 terms. As always, we'll first check for a GCF, but these 3 terms have nothing in common. And so now we're going to try grouping. So we check the GCF, done. So now we'll try grouping. The idea here is to get an equivalent expression with 4 terms, so I can use that method. And this is how we're going to do it. We're going to split up the middle term, that linear x term, into 2 separate terms. That way we'll have 4 terms. And it makes sense why we do that. When we write quadratic trinomials, we write them in descending order. And remember, for grouping to work, we need our first term and last term. When we take their product, in this case 30x squared, and that's going to have to equal the product of those middle 2 terms. Well, I'm off to a good start. When I split up the x term, I'll have 2 x terms, and when I multiply 2 x terms, I will get an x squared term. So now my strategy is to think of all the ways for 2 x terms to multiply to 30x squared. 1 divides everything, so I always start with 1x. And in this case, we'll get 30x as my other factor pair. What else divides 30? Let's go in order so we don't miss any pairs. 2 divides 30, so I have 2x and 15x. 3 divides 30, so I get 3x and 10x. 4 doesn't divide 30, but 5 does, so I get 5x and 6x. And now that I've hit 6, I start to repeat my factor pairs, so I know I've hit them all. Now that I have all my factor pairs that multiply to 30x squared, I need to check to see that when I add them, I get a sum of 11x's, which is my middle term. And quickly I see that this pair works. Their sum is 11x, which is just what I need. So this tells me how to split my middle term. I'll put 5x's here and 6x's here. You may ask what would happen if I put 6x's here and 5x's here. And in the end, it doesn't matter. The grouping method will still work and I'll get the same two factors, just in different order. So now let's do our grouping. Let's group the first two terms and the last two terms. And look at our first two terms. What's the greatest common factor they have? They both have a factor of x, so I'll pull that out. And on the first term, I have a 6x left, and on the second, a 5. So you can check if I redistribute that, I'll get my 6x squared plus 5x back. Now we bring down the addition symbol and look at my second group. 6x and 5 don't have a greatest common factor other than 1. But when I'm using the grouping method, I have to pull something out, so I will pull out that GCF of 1, and that leaves me with my 6x plus 5. And now once again, let's point out that we really have two big terms here, and that those two terms have a common binomial factor. So I can pull that binomial factor off, or factor it off, and I'm left with x on my first big red term and 1 on my second. That's what I have left. And so now I've completed factoring, and if you multiply that back out, you should get my original polynomial back. Now I'd like to show you just one more example. So here's another quadratic trinomial, and of course I'll check for a GCF first, but these three terms have nothing in common other than 1. So let's try grouping. So we want to split up that linear middle term, and if grouping is going to work, I have to do it in a way so that those two x terms, their product, will equal the product of my first and last terms. So there's my first and last terms. Their product is 14x squared. And let's think of all the ways we can multiply to 14x squared. So if I have 1x, 1 divides everything, I always check that first, times 14x. 2 divides 14, so I can have 2x and 7x. And now 3, 4, 5, 6 don't divide 14. That brings me to 7, and I know I have all my factor pairs. And so now I need to check the sums of these pairs. But I see that this first pair gives me 15x, the second pair 9x. Neither of them match my middle term of 4x. And what that tells me is that grouping is not going to work. And so I can stop trying to factor. I've already checked the GCF, and by checking all the factor pairs, that's why I want to make sure I don't miss any, I know that grouping won't work, and I can stop. In fact, since I can't factor this trinomial over the integers, we call this prime, like numbers that can't be factored any further. Okay, let's review everything we've talked about. First, quadratic trinomials can sometimes be factored by grouping, which is a method for factoring expressions with 4 terms. And grouping only works if the product of the first and last terms equals the product of the middle two terms. So for quadratic trinomials, the strategy is to split that middle linear term, x term, into 2 terms so that the rule works, and then we can factor by grouping. And finally, if the linear term can't be split so the rule works, then the trinomial cannot be factored by grouping. And now you know how to factor a quadratic trinomial by grouping.